saw a clever post about Wordle the other day on Kaggle, where someone found a way to solve the game on the first guess. So no involvement of what letters are being used or what position they're in, and giving it that feedback you've gotten so far, but just letting it look at the possible answers that the game can support, and looking at what posts people have made to social media that day. By taking each of the possible 2,000 or so answers, and the 10,000 or so possible other words that might have been used as guesses, it simulates some number of games to play and figure out what possible combinations of squares might be given as feedback. In social media posts, we often see the sequences of green, yellow, and gray squares to represent the letters that are in the answer and in the correct position, yellow meaning letters that are in the answer but in the wrong position, and gray meaning letters that are not present at all. And you typically see these various posts being made on social media so that other people can see what you did so far. And this is part of the interesting social aspect about the game itself. You can see these, but they're not giving away the answer, though they might give you some simple hints about, well, this was easy for that person to solve or hard for that person to solve. Sometimes people have more spoilers in that clue, or in their posts. Unfortunately, today is one of those days, so you may want to avoid it anyway. And fair warning, there will be spoilers about the actual word for today in this video. So by taking these sequences of squares, the Kaggle post translates the green squares to the letter Y for yes, the yellow square to M for maybe, and the gray square to N for no, meaning that this letter is not present at all. And then also provides a matching function to say, how do I evaluate a given answer based on a given guess and return the same sequence of letters. So I've built the same thing in Deephaven. And our main strategy here is going to be, instead of just taking some offline body of data, we're going to live in real time scrape tweets from Twitter every 5 seconds right now. The script is picking up new tweets and using that to figure out what the likely guess is for the day. So here's the list of all possible answers, 2,315 answers that could have been in the game, and how many times each one has shown up as a possible answer today in the tweets it's found so far. And if we just sort instead of alphabetically, but by frequency, we can see that the most likely answer by a very narrow margin is the word humor. So the way this works is, every time a tweet comes in, every time a set of tweets comes in, we break it up to be the various guesses that they made, or the various feedback that the game gave them, not the guesses themselves. And then we can join that on some lookup table that we've built to say what possible answers could have existed for that tweet. And then we have to reduce this to the set of answers that fit every single guess in the tweet, every single feedback string they got. And then from this we can say, okay, based on those answers, what's the most popular answer in the game so far? And again, by a margin of one answer, we've got the word of the day. So how do we build this? I started off with a word set, the set of all Wordle answers that are in the game, some 2,300 words, and then all possible guesses. So this is the extra words combined with the possible answers, which is just shy of 13,000 possibilities. I've got a similar evaluate guess function that says, given a word answer and a word guess, return what the game would have given you as feedback. If the letter's in the correct position, we return a Y. If the letter is present but in the wrong position, we give an M, and if the letter is not present at all, we give an N. And the code I have here will say, let's take all the answers and rename the column to be answer, and we'll take all the guesses, rename the column to be guess, filter out the cases where the answer equals the guess, because the feedback is trivial, it's just going to be 5 Ys, and otherwise evaluate this function for each of the possible rows in that table. If we do this ourselves by just saying, okay, let's just take the top 500 possible answers and the top 1,000 possible guesses, we can cross-join them, and we get a 250,000 rows here. Let's see, there we go, 500,000 rows. Oh, right, because I said 1,000. We filter out the handful where the answer matches the guess, and that brings us down to, it knocks out just a couple. And then we evaluate some extra column here. I need to actually run the function once first. we add one more column to say what the feedback would have been. So for the word ninja and a back, we have a matching A, but nothing else. So we just have a maybe row here, or maybe entry here, and all the rest are N's, for example. And then we select distinct, because it's not actually interesting which word would have been guessed. It's only important to say what the feedback was. And we only need to see each feedback string once. So now we're going to go from 500,000 rows, select distinct this data, and we'll be down to, it's going to take a little while longer to aggregate this, 40,000 rows. So from this, we've got our guess table, and that 40,000 rows applies only for the first 500 rows here. For the full list of possible words, we're up to 300,000 rows. We've got the tweets themselves, which we scrape by saying every 5 seconds get no more than 20 tweets, and keep track of what ID we saw last, so we don't accidentally see that one again. We only continue past that. We have to search to only find posts that have Wordle and then the number in them. And then we've got some code to say how exactly do we make HTTP calls, how do we decode the JSON in our Python code here. And then once we've got that, we can write to the Java portion of Deephaven to say, here's some row that includes all the details about the tweet, the text of it, the date time it was posted, retweet count, etc. And then log some details so that we can see how many rows have just been added. Given this table here with the raw data, we build a function which says, just like we saw in the Kaggle post, replace the Unicode for Y, M, and N with just, the Unicode for the different colored squares with just Y, M, and N. My version is slightly different here. I look only for patterns of 5 squares, just because some tweets happen to have more squares because people are drawing pictures with that. And then if there happens to be a all Y entry, we can exclude it here as well. It's not helpful to say that there's an all Y entry for the word. And then we get to what I call the wisdom of the masses here. It is the set of guesses that applied for each tweet and how many guesses it took them to make it. So this first row I have here filters out some other Wordle clones for other languages that happen to use the same numbering system, so they still match the, sorry, we need to start this again. My Python is somewhat poor and it sometimes loses tweets. Other Wordle implementations out there might reuse the same number instead of restarting at 0, or it's restarting at 1 when they started their game. And so we have to filter those words out here. And then we say, run our function up here to figure out what the guesses could have been to extract those words and put it into an array. And now we've got an array column. We still want to keep the array column for the possible entries. We want to keep the tweet ID, and we also want to add one new column for guesses, which is the number of guesses that the user made. This is going to strip off all the other columns because we don't need them anymore. And then an ungroup, which says unroll this array to make each entry that would have been in the array its own row in the table. And finally, for performance, we do an update, which says take each entry that was unrolled and actually create it in one gigantic column that holds all these values. And that just makes our later lookups a little bit faster. So here's some feedback that we have being displayed up here. The count of how many tweets we've gotten, how many distinct tweets we've gotten at this point that still had useful Wordle data in them. And then from that wisdom of the masses, we cross-join it with all the possible guesses. So now we've gone from our guesses table having 300,000 and our wisdom of the masses having only 4,000 so far. Our matching answer is going to be 8.7 million entries so far. And this is growing every time a new tweet comes in. And this represents, for this tweet, for any one row they had, what answers possibly could have matched. And the next one we have says, okay, given that set here, and it crashed out again, given that set here, let's find the unique sets of tweet ID and answer. Guesses is already going to be unique by tweet ID. And find out how many rows you got. And make sure that that count matches our guesses count. And that is to say that if there were 4 rows of guesses, make sure that each row matches the same answer. If you came up with an answer that only matched 2 possible rows, it isn't actually going to be an answer that's possible, so we can filter that out. And now, given this answer matches all guesses, which is substantially smaller, only 2.5 million, we can aggregate this to find out which answers are most popular, and then sort descending by that frequency. And that gives us our popular answer, and by now we've gotten a little more of a margin with humor. For some days we get a bigger margin between the winner, and other days we get a smaller margin, and that varies mostly based on how unique the possible answers can be, the possible feedback can be for that particular word.